Right now, at this exact moment, something ancient is landing on your face. Not a metaphor, not poetic license. Actual particles of light, photons, are hitting your eyes, your skin, the ground beneath your feet. They've been traveling for over 10 billion years. They left their source before the Earth existed, before the Sun existed, before anything in this solar system had assembled from dust. And yet here they are, landing, right now. They came from the largest confirmed black hole humanity has ever found. 66 billion times the mass of our Sun. An object so massive that its event horizon, the point of no return, stretches more than 30 times past Pluto in every direction. A hole in space so wide that a beam of light, the fastest thing in the universe, would need 2 full weeks just to cross from one side to the other. Its name is Canes 618. It sits 10.4 billion light-years away. It should not exist. Not at its size. Not at its age. Every model we have says it couldn't have formed this fast. And yet here it is, sending us light, and we are only beginning to understand what that light is telling us. What a black hole actually is. Before we talk about Canes 618 specifically, we need to fix something. Because the mental image most people carry around when they hear the words black hole is wrong. And that wrong image makes everything that follows harder to understand. Here's the myth. A black hole is a cosmic vacuum cleaner. It sits in space and sucks things toward it. Stars, planets, light, all of it gets pulled in like water down a drain. That's not what happens. A black hole is simply a region of space where an enormous amount of mass has been packed into an extremely small volume. That's it. Mass creates gravity. More mass, more gravity. And when you concentrate enough mass into a small enough space, the gravitational pull at the center becomes so extreme that not even light can escape it. The boundary where that happens, the point of no return, is called the event horizon. Think of it not as a wall but as a one-way door. Cross it and you've permanently exited the universe as you knew it. No signal can escape back out. No information. Nothing. The universe behind that threshold stops being a future you can ever return to. Now here's the part that surprises people. If you replaced our Sun with a black hole of identical mass right now, Earth's orbit would not change. Not at all. We would freeze in the dark, yes, but gravitationally speaking, nothing would move. Because the pull of a black hole is determined by its mass, not by the fact that it's a black hole. Distance matters enormously. Get far enough away and a black hole is just another massive object. This is why black holes don't reach out and grab things that aren't already on a collision course with them. You have to get extremely close, well within the event horizon's range, before the pull becomes inescapable. So what kinds of black holes exist? Most fall into 2 broad categories. Stellar mass black holes form when a massive star collapses at the end of its life. The core implodes, the outer layers explode in a supernova, and what's left is a black hole weighing anywhere from a few times to a few dozen times the mass of our Sun. These are the common ones, the ones we detect through gravitational waves when they collide. Then there are supermassive black holes. These anchor the centers of galaxies. Our own Milky Way has one, Sagittarius A*, weighing roughly 4 million solar masses. For a long time this sat near the top of what astronomers expected to find. Large, yes. Impressive, certainly. But comprehensible. Something that fit within the framework of what we thought we understood about how mass accumulates over cosmic time. Then, somewhere in the archives of old photographic plates, someone noticed a faint blue dot. And everything changed. The discovery and the numbers. In 1957, during a routine sky survey at the Tonantzintla Observatory in Mexico, a faint blue point of light was catalogued and promptly forgotten. It was listed as entry number 618 on a survey sheet, TN for Tonantzintla, 618 for its place in line. Nobody gave it a second thought. It looked like an ordinary star, unremarkable. It took 15 years for anyone to realize that was wrong. By the early 1970s, improved spectroscopic instruments revealed something strange about that faint blue dot. The light it was emitting had been stretched, redshifted, to a degree that suggested the object was not a star at all. It was a quasar, the blazing, active feeding core of an extremely distant galaxy. The light wasn't coming from nuclear fusion in a star. It was coming from a supermassive black hole surrounded by a disk of superheated, infalling matter so luminous it outshone every star in its host galaxy combined. Quasars were known by then. What made TON 618 different was its distance. When astronomers calculated how far that light had traveled based on its redshift, the answer came back: just over 10 billion light-years. The light reaching us had left when the universe itself was less than 4 billion years old. Young, chaotic, still assembling its first galaxies. And the object producing that light was, by any reasonable standard, impossible. Here are the numbers. Our Sun contains 1.3 million Earths. It is not a small star by human standards, though by galactic standards it sits somewhere around average. The biggest stars in the Milky Way dwarf it by hundreds of times. But all of that is context for one figure. TON 618 weighs approximately 66 billion solar masses. Some revised estimates put it closer to 40 billion. Either number is so far outside normal experience that the difference barely matters. Astronomers had to invent a new category for an object this heavy. They call it ultramassive. Take every star you have ever seen with the naked eye, every constellation, the entire visible sweep of the Milky Way on a clear summer night. Compress all of that mass into a single point. You would still need dozens of galaxies more to match TON 618. Its event horizon has a radius of roughly 1,300 astronomical units. 1 astronomical unit being the distance from Earth to the Sun-Pluto orbits at about 40 astronomical units. TON 618's event horizon extends more than 30 times further than that in every direction. Edge to edge through the center, that span is approximately 2,600 astronomical units. You could line up dozens of complete solar systems, Sun to Pluto, across that diameter and still have room left. And light, which travels at 300,000 kilometers per second, would take roughly 2 weeks to cross it. 2 weeks for a single hole in space. What it's doing and why it shouldn't exist. TON 618 is not a dormant black hole quietly sitting at a galaxy's center. It is a quasar. That means it is actively feeding, and feeding at a scale that strains the imagination. As material spirals inward toward the event horizon, gas, dust, entire stars, it forms what's called an accretion disk. The friction and compression inside that disk heats the infalling matter to temperatures of millions of degrees. That superheated material glows. And in the case of TON 618, it glows with an estimated luminosity of approximately 140 trillion times the brightness of our Sun. Put that another way, if you place the entire Milky Way, all 400 billion stars of it, right next to TON 618, the quasar would outshine the galaxy by a factor of several thousand. One object, brighter than thousands of galaxies. Stars that wander too close don't fall in as intact objects. They get torn apart by tidal forces long before reaching the event horizon. Stretched into thin streamers of gas, spun into the disk, heated until they radiate across every wavelength, and then swallowed. Astronomers call these tidal disruption events. We've observed smaller versions around smaller black holes. At the scale of TON 618, entire star clusters could be consumed across a single human lifetime, and the quasar would barely register the addition to its mass. And here is where the story stops being merely astonishing and starts being genuinely troubling to astrophysicists. A black hole with 66 billion solar masses should not have been possible only 4 billion years after the Big Bang. Black holes grow in two ways. They absorb matter, and they merge with other black holes. Both processes take time, significant time. A stellar mass black hole feeding at the theoretical maximum rate, a threshold called the Eddington limit, doubles in mass only every few tens of millions of years. Run those numbers. Start from a single stellar collapse. You cannot reach 66 billion solar masses in 4 billion years. The math doesn't work. So astronomers have proposed 3 explanations, and none of them are comfortable. The first is direct collapse. In the early universe, vast clouds of primordial gas may have bypassed the normal star formation process entirely and collapsed directly into black holes of perhaps 100,000 solar masses. Starting from a seed that large gives you a massive head start. The second is runaway mergers. In the dense, chaotic cores of the earliest galaxies, massive black holes may have merged with each other in rapid succession, each collision producing a larger, faster-growing monster. The third is the most unsettling. Primordial black holes, formed not from collapsing stars but from density fluctuations in the first fractions of a second after the Big Bang. They would predate stars. They would predate galaxies. They would be a product of the universe's first breath. We don't know which explanation is correct. We may never know. What we do know is this: the early universe was building things it wasn't supposed to be able to build. Ton 618 is the evidence. What's heading toward us, and what it means. Let's return to the question that's probably been sitting in the back of your mind. Is Ton 618 coming toward us? The answer has 2 parts, and they say very different things. Part 1. The object itself is not. The expansion of the universe is carrying Ton 618 away from us, and that recession is accelerating. Every year, the physical distance between Earth and that black hole increases. In the most measurable, most literal sense, Ton 618 is retreating into the dark. There is no gravitational threat. The math on this is clean. It is too distant to affect us in any physical way, and it is getting farther, not closer. Part 2 is harder to dismiss. The light is coming toward us. Right now. Photons that left Ton 618 when the universe was less than 4 billion years old. When Earth did not exist, when the sun did not exist, when there was no rock, no ocean, no atom arranged into anything you would recognize, have been crossing space for over 10 billion years. They survived the journey. A fraction of them reached us. They are hitting telescope mirrors on mountaintops around the world tonight. They will keep arriving for as long as anyone on this planet keeps looking up. So yes, something from Ton 618 is heading toward us. It has been heading toward us for 10 billion years. It has already arrived. What the light carries when it gets here is not a threat. It's a message. And the message is uncomfortable. Every textbook model of black hole formation, every timeline of galactic evolution, every assumption about how mass accumulates in the young universe has to make room for Ton 618 and objects like it. The James Webb Space Telescope, since beginning operations, has been finding supermassive black holes in galaxies so young their existence is theoretically inconvenient. Objects already grown to billions of solar masses in a universe only a few 100 million years old. Astronomers are calling some of them little red dots. The deeper we look, the more of them appear. The more of them appear, the clearer it becomes that the early universe was not the slow, patient, incremental builder we assumed. Ton 618 is not unique. It's simply the largest one we've confirmed so far. That record will almost certainly fall. Somewhere in the unprocessed archives of old sky surveys, a larger object is probably already sitting on a photographic plate, waiting for the right astronomer to notice. The same way Ton 618 sat unrecognized for 15 years. We cannot visit it. A spacecraft traveling at light speed would need more than 10 billion years to make a one-way trip. We cannot study it up close. We cannot send a probe. All we will ever have are its photons. Tired, ancient, stretched by the expansion of space. Carrying a story we are still learning to read. But those photons have shaken the foundations of what we thought we knew. And every night they keep arriving, each one a small piece of evidence from a time before this world existed, whispering the same thing. You do not know how big the universe's monsters can get. You do not know how fast they grew. And somewhere out there, past the edge of what any telescope will ever see, the one that sent this message is still feeding. It is still there, and it is still growing.